So someone hands you back a phone, or you're prepping one to resell, or you're reusing a piece of hardware for a brand new account session, and the very first move everybody makes is the same one. Factory reset it, tap the button, wait a few minutes, and just assume that whatever was on there before is completely gone. That assumption is only half true, and today I want to walk through exactly what a factory reset does, what it actually leaves behind, and why that gap matters a whole lot more once you're not just handing a phone to your mom, but running the same box across multiple sessions or multiple accounts. I run cloud Android hardware for a living, real physical phones sitting in a rack in Singapore on dedicated hardware, not some kind of simulation running on a server somewhere pretending to be a phone. Reset behavior is something we think about constantly, because a device that looks perfectly clean in the settings menu isn't always clean at the layer that actually matters. And if you're doing anything serious with multiple accounts, that deeper layer is exactly where things quietly go wrong. So let's start with what actually happens the moment you tap erase all data in settings. The phone reboots into something called recovery mode, and recovery runs a wipe against two specific partitions, the user dial partition and the cache partition. That's the entire mechanism, start to finish. The operating system calls into recovery. Recovery mounts those partitions and it wipes them clean. And this is the same basic path no matter how you trigger it, whether you tap the button inside settings, whether you hold down volume and power to reach the physical recovery menu, or whether an MDM system pushes a wipe policy remotely from somewhere else entirely. Same path, same result, every time. Now let's look at what's actually sitting inside that user dial partition. That's where your apps live, your app data, your signed-in accounts, your downloaded files, and most of your personal settings. Basically everything you as a user did to that phone after it left the factory floor. The cache partition goes along with it. But here's the part people consistently miss. The system partition, the actual operating system itself, is untouched by a standard reset. You are not reinstalling Android when you do this. You are only clearing out everything that got layered on top of it afterward. Here's something you've probably noticed before without ever stopping to ask why. Compare how long a factory reset actually takes against how long it would take to genuinely overwrite tens of gigabytes of flash storage, block by block, sector by sector. The reset finishes way faster than a real overwrite ever should. And the reason is that since Android 10, file-based encryption has been mandatory across the entire platform. So most resets today aren't a full data blanking overwrite at all. They're what's called a crypto erase instead. Think about it in concrete terms for a second. A typical phone today might carry somewhere around 128 gigabytes of storage. Physically overwriting every block of that at realistic flash write speeds would reasonably take several minutes, maybe longer depending on the chip. But a factory reset on that exact same phone finishes in under a minute, sometimes closer to 30 seconds once you strip out the reboot time. That gap right there is the tell. You're not watching a phone get wiped block by block. You're watching a phone throw away a key. Let me actually explain what that means in practice, because this is probably the single most important technical detail in this whole topic. Everything sitting on the data partition is encrypted at rest, and the encryption keys themselves are stored in a hardware-backed key store, usually tucked inside a trusted execution environment or a dedicated security chip on the board. A factory reset can simply destroy those keys instead of overwriting every single block of storage that ever held your data. Once the key is gone, whatever ciphertext is left sitting on the flash chip is completely unreadable. Functionally, it's just as good as erased, without paying the time cost of physically rewriting every sector on that chip. It's genuinely smart engineering. But wiped here means cryptographically unrecoverable. Not every bit on the chip got physically flipped, and that distinction is going to matter a lot for what comes next. So what actually survives a factory reset? This is the part that trips almost everybody up, because most people assume reset means back to exactly how the phone left the factory. It does not mean that at all. The bootloader stays exactly as it was before. If the device had an unlocked bootloader going into the reset, it still has an unlocked bootloader coming out the other side. That particular state lives entirely outside the partitions that get touched. The Banong firmware and its low-level settings are also left completely untouched. That's because those live outside the data partition altogether, and they're managed by the baseband processor, a totally separate chip handling radio communication, not by the Android operating system layer at all. Wiping Android simply doesn't reach into the baseband. Then there's what's called DRM provisioning, specifically the Widevine device ID, which gets used for protected video playback, think streaming services like Netflix and plenty of others like it. That ID is tied directly to the hardware, and it does not regenerate on reset. Same story for hardware attestation keys. Those get burned in or provisioned back at the factory during manufacturing, and they're used to prove to some remote service that a device is genuine, unmodified hardware. None of that moves even slightly when you tap Erase All Data. The IMEI and other hardware identifiers are obviously untouched too. That part isn't even a surprise to most people. There's also something called the persist partition on most devices, holding calibration data, sensor configuration, and other low-level settings, and the normal reset leaves every bit of that completely alone. None of this lives in a partition that a standard wipe ever touches, and honestly none of it should, since a lot of it is tied to radio certification or content licensing that has nothing to do with your personal data at all. Now here's a wrinkle that genuinely changes what reset means for whoever gets the device next. If a Google account was signed in and Find My Device was active before you wipe the phone, Android's factory reset protection kicks in automatically the moment the wipe finishes. After the reset completes, the setup wizard is going to stop and demand the credentials of a Google account that was previously on that device before it lets anyone move forward at all. That's an anti-theft feature by design, and it's exactly why second-hand phones sometimes show up locked at setup with what looks like no way through. I've actually seen this exact scenario play out with second-hand hardware, where somebody wipes a phone with good intentions, hands it over to a new owner, and that new owner gets stuck sitting at a screen asking for an email address and a password they've never seen in their life, with genuinely no way past it except tracking down whoever owned the phone originally. And this is really the practical takeaway from all of that. Reset and ready for a brand new account are simply not the same event. You need the previous account properly signed out and that protection fully cleared, not just a wipe triggered blindly, or the next session gets stuck sitting right at the lock screen asking for credentials that nobody has anymore. If you're managing hardware across sessions for a living, that's step one you genuinely cannot skip. Now let's talk about identifiers, because this is the part that matters most if you care at all about device fingerprinting. And honestly, almost every app that cares about account uniqueness does care about this in some form. The Android ID, which gets scope per app signing key and per user on the device, does regenerate on a factory reset. The Google Advertising ID resets too, since that one's managed by Play Services, and Play Services reinitializes as part of the setup flow. Those are software layer identifiers, and the wipe genuinely does rotate all of them. Intel hardware-backed identifiers are a completely different story though. The Widevine device ID, the attestation keys rooted in the secure element, and the signals derived from Play integrity checks that reference actual hardware state, none of that moves an inch. A well-built fraud detection, or multi-accounting detection system, on the platform side isn't only looking at Android ID or Advertising ID, because both of those are trivial to rotate with a simple reset. It's also looking at hardware attestation, and that layer sees straight through a factory reset every single time, without fail. The device is the same device, cryptographically provably so, before the wipe and after it. Picture how this actually plays out on a single piece of hardware. You take one phone, you install an app, you sign up for an account, you use it for a couple weeks, then you wipe the phone and set up a second account on that exact same hardware. From where you're sitting, that looks like two completely different phones, new Android ID, new Advertising ID, clean storage, no trace of the first account anywhere a casual look would find. But if that platform runs any kind of serious attestation check, it's still seeing the same secure element, the same attestation certificate chain, the same Widevine device ID it saw during the first account's entire session, two accounts, one underlying hardware fingerprint, and that correlation is exactly the kind of signal that gets accounts linked and band together. So why does any of this actually matter in practice? If you're just handing your old personal phone to a family member, none of it matters even a little bit. But if you're cycling the same physical box across sessions, where each session genuinely needs to look independent to whatever service is checking on the other end, a factory reset alone simply does not get you there. The bootloader state, the attestation chain, and the hardware identifiers all stay perfectly consistent across every single reset you run on that same box. You've cleared the app data, you've cleared the accounts, but the hardware fingerprint sitting underneath all of it hasn't moved one bit. This is the actual practical reason we run dedicated physical hardware per profile, rather than treating reset cycles on shared boxes as if they were somehow equivalent to fresh devices. A real reset gives you a clean data layer, and that part is genuinely true. It does not give you a clean hardware layer, and for anyone doing serious multi-accounting work, the hardware layer is exactly what gets checked first. Separate physical devices, each with their own provisioning history and their own attestation chain from day one, behave the way independent phones actually behave, because they genuinely are independent phones. There is no reset shortcut anywhere that substitutes for that, no matter how many times you wipe the same box. Alright? So if you want the short version of absolutely everything we just walked through, here it is. A factory reset wipes your data partition, and on modern Android, it does that by discarding encryption keys rather than physically overwriting storage. It does not touch the bootloader, it does not touch modem firmware, it does not touch DRM provisioning, and it does not touch hardware attestation keys. Some identifiers rotate on reset, others simply don't, and the ones that don't happen to be exactly the ones platforms rely on for hardware level fingerprinting. Knowing that difference is genuinely useful, whether you're just prepping an old phone for resale, or you're actually thinking through how real account and session isolation needs to work at the hardware level. For 4.7Today, we run real cloud Android phones in Singapore on dedicated hardware, each one with its own persistent Singapore mobile IP, so every single session actually behaves like a genuinely independent phone from the ground up, and you can find all of that over at cloud.one. If you found this useful, go ahead and subscribe for more breakdowns just like it.